So thank you guys for coming out today. It's the last talk of the day. I know you've been just hammered with information left and right. So you could be anywhere in the world right now, but you decided to be in this room with me. This was a dual project, myself and my colleague Donald Miller. Donald can't make it today because he got called away from work in another country, so you're stuck with me. So today is Has Arisen is the name of this talk, right? So use XXE to your Canadian environment. So I've spoken about XXE, I believe, back in 2015, 2016 at BSides Charleston. And it was before, obviously, the new OWASP Top 10 came out in 2017. But it started off as a project, a senior project while I was in college, while I was studying service-oriented architecture. So it's just a really fancy way of saying, like, when you go purchase an airline ticket, it locks your airline ticket or a movie ticket or any kind of ticket for a certain amount of time. So from there, my friend turned me onto this, and I just kind of dug into it, learned a lot, learned more and more and more about it, and the ins and outs, which we'll cover in this slide today. So a little bit about me. I'm a cyber operations officer in the South Carolina Army National Guard. I've been doing Army stuff for the last 12 years. During these 12 years, I started doing cyber stuffs probably back in 2008 when I was a little private in Korea. I officially became a student. Carrying that forward, active duty. I left active duty after my last deployment. Went to school at College of Charleston, down in Charleston, South Carolina, for studying to be a computer science major, studying for pretty much as my first introduction to programming. It was totally daunting, but I was super interested in cybersecurity. So from there, went on and made a cybersecurity club, which is, I guess, grew, which is super awesome. Through there, started getting into a little bit of consulting for a startup firm called Satera, which is a sponsor for this for BSidesAugusta today. And then through that, a technical mentor at Node SC, which is a nonprofit organization in Charleston, South Carolina, that focuses on teaching information technology, cybersecurity, and business entrepreneurship to the high school, college, and college students in the local community. I'm a code monkey, so I've been wanting to get my developer chops up. So from this project, I'm going to demo a tool called Doulos that's written in Python that kind of automates this process of creating XML payloads to test for this type of vulnerability. I'm a builder of Legos. I like to build a lot of Legos, and I recently have been trying to figure out how to make the perfect old-fashioned, which is harder. Up top is a photo of Clyde the Cougar, which is a College of Charleston mascot. This is me getting Clyde's ring. So fun fact, I was the mascot for College of Charleston. So you know what I look like. Here's what I look like as Clyde, right? So here's our roadmap for today. So today we're going to cover what is XXE and what we can do with it, the different XXE attacks and the types. But in order to understand XXE, you have to understand how XML works, which is pretty simple. We'll cover a demo, then we'll cover some defense against XXE. We'll talk about what kind of payloads, what kind of detections you could be looking for, questions you should be asking yourself. Red, blue, and purple teams, how they can use XXE, and then we'll open it up to questions at the end. So key takeaways, right? So for this talk, if you pay attention to nothing else I say, I want you to understand how XML works and how it can be used for good and bad. I want you to understand how web apps are exploited using XXE. And then understand and see the attack through the eyes of the red team, the blue team, and the purple team. So what's pretty important, and I would strongly encourage that you keep an open mind when I go through this material and think about ways that through a SOC analyst or a threat hunter can look at this type of information and say, what can I glean from this? What kind of behaviors can I find? What kind of signatures can I write? Really understand at a deeper level. You red team guys, it's kind of more of a technical talk, so we're going to be exploiting a simple web server to demonstrate this proof of concept. But also look at it through the blue team's eyes, right? And then the purple team is kind of, it's blend between the two, and we'll talk about more of that in detail. So, so what is XXE, right? So it's not sexy. It's not like, I got remote code execution through XXE, which very rarely happens. But it's an XML external entity attack, and it's a type of attack that occurs against an application that parses XML input, right? So any type of application that you write, Java, PHP, Python, if there's a parser library or the language can parse XML files, it's a possible vulnerable application, right? So this attack occurs when XML input containing a reference to an external entity is processed by a weakly configured XML parser. So in a nutshell, what this means is that you craft your XML payload, whatever it is, you push the payload to the XML parser. This could be through a SOAP or REST process, but also just curling the file to a parser that you're looking for, which is the demo I'll be showing today. But it could also be a file upload feature, right? So if you have a web application that allows users to upload files, Slack, SharePoint, those kind of things, 9 times out of 10, it accepts XML, right? Excuse me, your parser interprets your payload, right? And then from there, pwnage, hopefully, fingers crossed, no whammies that you actually get it going, right? So what can we do with XXE? Again, remote code execution is rare, but if you're already going down this rabbit hole, simple check. Let me just see if PHP has this module loaded on this web app, right? So you got denial of service, so the billion laughs attack. It's essentially an entity that calls another entity that calls another entity, right? So again, you're just going to slam that server with calls. Server-side request forgery. So I want me, the user, to interact with this server, and I want you, the server, to go out and show me something. But I don't want what you're pulling to know I asked you to do it. I just want you to do it. Don't tell nobody. And then when you get it, let me know that you got it and show it to me. But it's our little secret. Directory traversal is pretty self-explanatory. Navigate, enumerate the directory, port scanning, and local and remote file inclusion. All right, so now we're going to go over an overview of XML. So XML is an extensible markup language. It derived from the standard generalized markup language, so it falls from the same family of HTML. The international in HTML is the international standard for defining markup, right? It's software and hardware independent. So when hardware and software designers came together, they're like, we need a language we can use to transport data that's super simple, it's easy, it's lightweight, it doesn't have a high overhead, and it's pretty simple to pick up, right? So in the next slide, we'll see an example of this, but XML looks exactly like HTML. You got your closing tags, you've got your strings, your data, whatever is parsing through, right? But what's particular to point out is that HTML is used to display data, right? So colors, images, videos, pleasing to the user of your web app, of your web page, whereas XML is purely used to be storing data and transport data across your network, right? So if I have two custom applications and they need to talk to each other, well, how can I do it? Well, you can look at your options, but XML might come up in conversation for you to do so. So from there, how can server 1 talk to server 2 and pass data back and forth so that server 1 and 2 are both speaking, quote unquote, the same language, right? So what uses XML? Microsoft Office, Apple iWork, OpenOffice, LibreOffice. You see a trend that's happening here with the file upload feature, right? So you can imagine where this came from. SVG images, XHTML, and XCSS, which is XML. It's HTML written in XML, so it's kind of like Jython, Java, and Python. Bananas. HTML5, RSS atom feeds, and then SOAP and REST web services, right? So now let's actually start digging into a little bit more into the XML. So let's put our nerd hats on. So all XML files must be well-formed, right? So, well, Leo, what does well-formed mean? Well, they have to have a root element, right? So you have to have a root tag. All of this is comprised of this one thing. That root element must have a closing tag, and all tags sub underneath that. Tags are case sensitive and must match. They also must be properly nested. All attribute values must also be quoted. XML does not require document type definitions, but they can and do use them. So today, the proof of concept will be calling out to, a web server that grabs a document type definition file, reads it, and then spits out stuff elsewhere. Essentially, your XML follows correct syntax. So that's what well-formed means. And then all XML values that use the DTD must be valid, right? So what is valid? Valid is, does your DTD match what your XML file states? So if your XML file is valid, it's also well-formed. It's naturally assumed that it's well-formed. This is kind of where you can start getting into shaky ground if it automatically assumes things, right? So this is a well-formed example. So here we have the top line, right? So the top line, XML version 1, encoding UTF and standalone, yes. This is not a required line in XML files, but it helps, right? It helps the parser understand what type of file it's dealing with, and it doesn't have to guess. So here we have a root element of note. It's going to Kiki from Aubrey. It's got a question, and it's asking, do you love me, right? And it's a note, just a quick note. I think my thing fell. Like, what is that sound? Cool, right? So this is a well-formed example. So we've got our open and closing tags. We have a root element. Everything's nested. Everything's clean. Good to go. So now we're going to do a valid example, right? So it's the exact same XML document, but instead, I'm including a DTD file, a document type definition file, which states that I have an element, some element called note, that has a to, from, heading, and body elements, sub-elements to it. Each of those elements is a PC data type of element, and it stands for parse character data, right? So it's just simple plain text. Whatever is there, interpret it as it is. So if I have ASDF, 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 it's going to print ASDF, ASDF, ASDF right there, right? So, but what this means is that whereas before in the previous example, here XML, whatever is interpreting an XML file, has to guess at the root structure or the structure of this XML file. Here, it doesn't have to guess. It has a document type definition that says, look here, and this is how you should interpret this file, right? So next we're going to start walking into the different XXE attacks, right? So a little bit of terminology. So you have in-band, blind, and out-of-band, right? So your in-band is where you send an XXE payload and you get a response back from the web app containing some data within all the same browser or terminal window used to launch the attack, right? So I launch the attack and I'm going to get it right back. So file upload feature. If you are exploiting a certain variable or a certain thing in your web application and you upload a file to it and you say spit it out in this field, right? So a perfect example is username and password. So if you were to log into a username and password web app, for instance, underneath it might say welcome, and then it'll have a variable of username here. So to say welcome, whatever you set your username to. Well, if it accepts XML files and you upload it and you say instead of printing my username, I want you to print the variable that I stated in my XML file, and the variable I stated in my XML file is actually Etsy password file. So spit that out on my web page, and then it spits it out on your web page, and you're like, awesome, you're vulnerable, and I'm gonna see what else I can do with you, right? Next is blind. So an attacker can send a request with an XXE payload, get nothing but the errors. So from there, you're kind of poking the bear, trying to figure out, what can I do, and making the implicit explicit. So what is the application not telling me? And then Outofband is kind of like in-band. The only difference is that it's not going to spit it out in the same terminal or browser. I might have a netcat listener, or I might have some other thing that's accepting input that it's going to push it to. It could be an FTP server, could be your DNS logs, could be anything, right? So again, here's an example of your in-band, right? So it's going to spit it out in the response. Let's take a look at that. Here's a blind one, so something to pay attention to is this error. So it just gives me an arbitrary error. So I tried running this thing, and it said, oh, there's an error. You're like, oh, okay, cool. At this point, I know that it's accepting XML, right? And then next is your out-of-band, right? So now I'm running this right here. So saying entity and a variable called pass, going into the system, I want you to look for this file, XXE password. And then another entity called XXE in the system, I want you to make a call out to this IP address using this port and go to this page and then display the file XXE password. And then again, nested file reset, login, Kumar space, and then pass this in there, right? And then pwnage, you got your XXE password file. All right, so now we're going to actually walk into this demo. So it fell again. So I made a sacrifice to the demo gods last night. So hopefully this works accordingly. So from here, you guys can't see this. Can you see that? Yes. Is that better? Can you see that? Awesome. Cool. So you can't really make up this stuff up here in my terminal. But this right here is the actual code for my parser, right? Just a simple XML parser written in PHP. It's just accepting XML anything and then spitting it right back out to you, right? So I have an attacker terminal. So this is supposed to emulate the attacker typing in commands to get all the things. Next, I have a netcat listener. Which is essentially, it's just my listener listening for that callback that I get. And then I have the attacker-owned web server. So this is where I'm hosting my DTD, right? So I don't have a slide on this. It probably would have, in hindsight, it'd probably be better to do it. But how this attack will work is I have this vulnerable web server that is taking in XML, it's parsing an XML file. I have my own web server, AWS, DigitalOcean, whatever, that is hosting my DTD that I want it to run through. And then I'm going to pass that to pass a payload that I generated using a tool called Doulos that will generate the payload and the DTD needed for you to execute this attack. I pass the payload to the parser. The parser interprets it, says, oh, there's a DTD file. I need to go out to this IP address on this port file, analyze that, and then whatever it tells me to do, I'm going to spit that out to this other IP address / port on this netcat listener. So that's essentially what we're going to walk through, and that's what we're going to go through. No worries. Hopefully this works. So my tool is not open to the public yet because it's in its like pre-alpha phase, so it's super buggy. If you guys, I have contact information at the end of this slide deck, so if you want access to it to play around or contribute to it, just let me know. Just shoot me an email, shoot me a thing on Twitter, and I'll get you added and you can play with it. But in the near future, once I work out a lot of these bugs, I'll most definitely make it public for the community. So something to keep in mind is that we're running Python 3, right? So Python 2 versus Python 3, very, very different. So if you try running this in Python 2 and you're like, it doesn't work, it's not a bug. It's just, me and Don decided that we're going to move forward with Python 3 and not make it backwards compatible. So from here, we're going to run a tool called Doulos. And I now realize that that is a terrible background for you guys. Is that better? Cool. Cool, cool. So tool called Doulos, little history. Doulos is the Greek god of trickery and other things, so I thought it was pretty clever that we're tricking web servers to do stuff. And then Halloween's coming up, so I said, why not put some Ghost on there? Cool, so also, fun fact, I had to pivot my talk 2 weeks ago because my exploitable web server that I had didn't want to be exploitable anymore. So initially I was using, creating an out-of-band payload using a docx file that did kind of the same thing that we're doing now with a file upload feature, but I could not get it to work 2 months ago, or 2 weeks ago when I could get it work 2 months ago. I don't know what happened, so I had to pivot really fast and throw this in there. So we're going to create an XML.text payload, right? So we'll choose number 2. It's going to ask what is the IP of the server that you're hosting your DTD. Right? So we'll go ahead and throw that in there. What is the listening port of your server that is hosting your DTD? So we're going to do 8000 because we're running just simple HTTP server using Python. Default is 8000. So what is the IP you want the victim server to call to? So same IP. And then what is the port you want the victim to call back, right? So 1337. And then it's got this error. So this also happened Friday. So I'm running in the wrong thing. Again, more bugs. That's what we wanted. So it created our payload. They stored it in the absolute file path. They created a DTD file, stored it in the absolute file path. So now we have our payload that we're going to push to the parser, and then we also have our document type definition. That's the instructions for what the web server is going to, what the parser is going to tell the web server to do with what we want, right? So now, what it is. So, I'm using nano. So, so from here, right? So we have a root element, right, of doc type, and we have an entity called remote. So it's going to say, we have an entity called remote that's saying go out to IP address, that IP address and that port, and pull the evil.dtd file, interpret it, and do whatever it says inside of it. And then from there, I want you to execute remote. I want you to then execute intern, and I then want you to execute XXE. So it's important to note that remote and XXE, they can be named whatever you want. Those are just variables. Those are just the variables that I selected. So now let's take a look at our actual meat and potatoes of this. These are the actual instructions, right? Now I have an entity called payload, because I'm lazy, and then PHP filter read in, so using PHP, read in this file, and then convert whatever that file is, Base64, encode it, right? And then the actual resource is the etc/password file. So that's one entity. The next entity is intern, right? But within intern, I have another entity called XXE that says, similar to what I demonstrated earlier, IP call back out to that port number and give me the result. Netcat doesn't care what, for those unfamiliar, Netcat doesn't care what you get or what is sent its way. If it's on that port and it's coming in, it's going to log it and it's going to put it to standard out, which standard out in this case is our terminal, right? So now, let's actually go ahead and start our stuff. So, make that a little bit bigger so you guys can see it. So now we've got our netcat listener. So I trip people up to Python 3. They changed simple HTTP server to HTTP.server. So that took like 10 minutes to Google. Like, why is this not working? Because you're in Python 3 now, guy. So now we have our server listening. We spin simple HTTP for your actual directory is the directory that you run on your server. So it was another quick 10, 20 minutes to Google, right? So now we've got a server that has a root directory of our payload folder. It's going to reach out and grab that file, execute it, right? I got a netcat listener on another port saying, give me all the things that you want to send to me. So now we will execute this. So we're going to curl D, actually, just so I don't mess this up. I did a lot of tests, right? So curl this file, pass in payload.txt to that IP address, and this is the attackers, or excuse me, this is the vulnerable web server's IP address, right? So you're not going to get anything back, and the reason why you're not going to get anything back is because there's really nothing to return, but your web server is actually calling out and doing the things that you want it to do, right? So you kind of still hang, you're just hanging there. But if we go to the actual server, we see a 200 for the evil.dtd, which means we got the file. Awesome. That's step one. Am I getting a callback? Or this IP address is some IP address reaching out and grabbing the evil.dtd file directly. That's a win. And then my netcat, I now have this Base64 encoded thing. So from here, you're like, cool. So also fun fact, the only way I could get this to work is if you encode it. So if you're doing XML stuff, this is why it's a kind of a piecemeal environment. You have XML code, but you're also using HTTP to move your stuff back and forth. And then you also are reading in system files like etc/password, etc/fstab, if you're into Windows, win.ini. And then you're passing the contents of those files through HTTP, right? So if there's a lot of times, there's a lot of characters that HTTP doesn't like, right? So you got to escape those characters. Easy way to do it is just encode it to something like Base64, which is used to transport stuff over the internet, right? So now we've got this Base64 string that we can then decode, right? So from there, let's go into Python, import Base64. Oh, it helps if I can spell, right? So then Base64 dot B64 decode. Again, if I can spell. Pass in that string, and then we now have the etc/password file of that machine. That's a win, right? Super, super duper awesome. So now, the end of the demo. So now we'll move forward and go into a little bit further, right? So that proof of concept that you just walked through, look at it through the eyes of your blue team member, right? There's a lot of things in there that you can kind of pick up on. Your Base64 encoding things, right? And you're passing it through a network. You have a web application that's reaching out to an external entity, an external IP, grabbing a file, and then running it and doing some stuff, right? You pushed a file to a web server, and that connection never closed, right? So that's something else too. That just might be terrible coding. I have no idea. But you have like a lot of things you could be, you can be on the lookout for. Through your red team's eyes, have a way ahead essentially for, another thing you can put into your bucket, right? When I've tried everything else, like what else can I try? Kind of deal. So now we'll move forward into defense against XXE and its limitations, right? So one limitation, XML parsers can break if they don't understand characters in your XML and DTD files, right? So what if I didn't want to encode it? What if I wanted to obfuscate it a little bit more? Well, there's something called CData, right? So CData says, hey, XML parser, if you see things between two tags, or if you see something that starts with CData in this very specific order, then just interpret it as it is. Like, don't try to do anything, just print it. I don't care. It just doesn't have to be. Let me take care of that. You just get it out there. That's one way of doing it, right? Next is the other one that we just talked about is Base64. So I had a really funny GIF here, GIF. But Mac, for our Office for Mac, doesn't like GIFs, whichever way you say it. So this presentation, I had a presentation crash on me 2 years ago, and I was like, oh no, what do I do? Right? But the example in our demo is PHP-based web application, you can Base64 encode it, right? So now let's go into detection and prevention. So I got a beer with one of my colleagues pretty recently, and he said one of the biggest things that a lot of people in our industry fail to do is how do I stop? How do I stop the bad guys? How do I get the bad guys? How do I find them? How do I get them out of my network? You know, like that train of thought, hammer, we got to get it out, right? But then nobody talks about detection. How do I detect, right? So everybody's heard the statistic, 200 plus days, adversaries sitting in your network, you have no idea, right? How do I get that number down to 90, 30, 4 hours, right? How do I bring that down in my own environment? Well, you got to learn how to detect it. And then that goes into the Purple Team talk that was going in today, what Dave Kennedy spoke about today with behaviors, tactics, techniques, and procedures. You're only focusing on the technique and then putting in the strings, but then I can change my string to do something else to get that looks different but gives me the exact same result, right? So one of the first things you can do if you want to catch this in your web application is just disable the use of external entities, period, right? So if you write a custom web application and you already define all your data types, data type of like Borg, whatever you define Borg to be, and you have those files internally, you should never see your web app reach out and grab another DTD file if you have it locally, unless you have like public. You can set public DTDs, which is WC cubed, I believe, the World Wide Web Consortium, so W3C, that define the XML specification. They have public that you can use. But if you see anything .dtd, typically if you create your own custom application, it's not going to change that, right? So that's one thing. Just disable it. Boom. Done. Very simple. Next, verify that your XML or your XSL, so your schema file for your XML, upload functionality validates your incoming XML, right? So if you have very specific parameters for your application, why don't we specify those very specific things and say, if it's not this, just don't even use it. Just throw it away. Dev null, random, or temp. Doesn't matter. Just get rid of it. I don't need it, right? And then patch upgrade your XML parser. So if you're running PHP 5, upgrade it PHP 7, older versions of Java, that sort of thing, right? OWASP has a super awesome cheat sheet for all the various languages that have XML parsers. And they're very, very, very simple to do and change. It's not like hundreds of lines of code. It might be like one line. Change this module from true to false. Boom, you're safe, right? But then, so that's how we can prevent it. But how can we detect it, right? So typically, if your stuff parses in JSON, why can you not just change it to XML? A lot of times, if web applications will read the content type headers for JSON, you can go into burp and say, oh, change that to XML, run it, right? It'll still spit out the same information, right? So it's like, oh, so you now take, again, doing blind stuff, it allowed me to change it, and I still got results back that is data. Let's change that to, what else can I do with it? What else can I do with XML, right? Let me go down this rabbit hole. Are there any outbound requests from your web server web app that shouldn't be there, right? If you have an internal web application, it should most definitely not reaching out to your to an external source unless you have it configured that way, right? Is there any use of Base64 in your environment? So I know in my environment as a SOC analyst, I see some things where I'll see Base64 and it's like, what is this? And really it's just sysadmins obfuscating their stuff through the network because they're trying to not get caught by the SOC guys. And then is your parser accessing directories and files it shouldn't, right? So that's a huge one. So if you have a file upload feature, why is your file upload feature going to your Etsy directory, right? It should be going to like user uploads or some other thing, right? So that's most definitely things you should be detecting on and be looking out for, right? And that's only one of many. It can get pretty hectic, right? So now we're going to go into red, blue, and purple teams and how they can use XXE, right? So I'm a geek and I'm a nerd, and I do a lot of technical stuff, as you can see. But my job as an officer in the Army does not allow me to always get to be the geek and the nerd. Sometimes I have to be the manager, the leader, and the supervisor. So I have to take groups of people and train them and get them trained in order to execute what I need them to be able to do, right? So this is kind of where I get into, I put my management and my supervisor hat on, right? So XXE through the red team's eyes. Again, I had another GIF, and it crashed my thing. So I found this guy in college who's just taking a nap, right? So XXE is not the sexiest thing, right? It's pretty boring in the eyes of red team members, because it's like, well, I don't get to pivot, I don't get to do all these, super cool things that make me look elite, right? But there's countless blog articles of people who were able to, through XXE, through SharePoint, for instance, in a Windows environment, was able to continue to escalate their privileges to domain admin, right? And that includes exploiting, creating an RDP user, and then from there you got your GUI. So then you go from simple user that has, simple SharePoint user upload to I now have, a Windows command prompt as a standard user that I can then elevate privileges through that to become an RDP user. So now I have a GUI to do stuff to obtain domain admin. There's also a couple instances where Facebook got popped with this a while ago. Slack got popped with this a while ago, right? So if you're doing bug bounties, doing fun things, right? Might be a cool time to try it, right? So through the red team's eyes, it can be used in all phases of the adversarial engagement, right? So just a quick question for my first giveaway. Your choice. What's the difference between penetration testing and red teaming in your own words? Yeah, so one is a particular thing of an adversary, right? So you're emulating an adversary. And the other one is just doing a service, right? So with that, I have 2 blue team handbooks and a wireless adapter. Which one do you want? You want a wireless adapter? Cool, it's right up front. So I'm going to use that, and then I'm going to add more. It fell again. I'm terrible at this. Struggling today. I'm on the struggle bus. So red team, right? So to add to that, in my opinion, this is Leo Pate's opinion, so if you have like the security onions, you can throw them at me if you want, if you don't agree. But penetration testing is typically limited in scope, right? Like he said, you're kind of testing for a service. You're testing, you have clearly defined left and right limits. You have a short suspense, and you got to do, like, find all the things, right? Whereas red teaming goes, like 3 layers deeper, right? Red teaming is emulating the adversary, thinking about the adversary. How does the adversary view your environment? How does the adversary, is in your environment, it's not just ones and zeros. It's not just things you can plug into, a power outlet. It's people. It's door alarms. It's, key fobs. It's your telephone system. It's where you live. It's your car that you drive, the route that you take, right? If I have an important sysadmin and I want to stop you from getting to the office to do stuff, well, why can't I have a team of people that knows the route that you take to throw up traffic cones and reroute you around the city, which adds an extra 30 minutes to your commute? Like, it goes to that level of extreme, right? So utilizing the penetration execution testing standards, XXE can be used in all of these things. Intelligence gathering, right? So port scanning, what files can I grab? What is the lay of the land? That sort of thing. Threat modeling, so nobody likes to do, but it's pretty important. How can I get into your network? how can I do things and get things done to achieve a desired result? Next is vulnerability analysis. So this is kind of, is your web app vulnerable to this? And if your web app is vulnerable to this, well then how can I use this to determine other vulnerability points within your network, infrastructure, whatever. Exploitation and then post-exploitation. So how do I exploit this? And then how do I get stuff out for exfil? Again, you're less likely to find RCE. This is more used for remote and local file inclusion and pivoting to other systems, a way in and learning the lay of the land. So that's really where XXE, in my opinion, comes into play. However, you're limited in options for exploiting web apps because you're very limited in the type of protocols you can use. FTP, DNS, what else? HTTP, right? So you're using these various protocols, but you're pretty limited, and you're only limited by what those protocols will allow you to do. But why can't you take a protocol like PHP and then encode it in Base64 in order to get your exfil data, right? So I'll argue that while you're only limited with those protocols, you are also limited by your own imagination and how you can string those together, right? So let's taking that a step further, right? So for the blue team people in the the blue team people in the room, this is the mindset that your red teamers, your adversary simulators, your penetration testers, this should be the mindset that they have, right? So next we'll go through the blue team's eyes, right? So again, 200 plus days, how can we get that number down? A really good way, and this is just one way, is the OODA loop. So how many of you have heard of the OODA loop? Right, so I see a couple of hands, right? So observe, orient, decision, make a decision, and then act upon it, right? So if acting, right, so 200 plus days is when you start to observe, right? So 200 plus days, you're like, oh man, I just discovered this person, or this entity is inside my network, right? So how do we cut it down? But until we can act, right? So do something and place a safeguard, get them out or not get them out. Maybe I just want to contain them a little bit, so I want to learn more about my adversary. What are their TTPs, their tactics, techniques, and procedures, right? And then, so from there, from this one proof of concept that I demonstrated today, right, I stated the only way you could do it, the only way I could get my data back is if I encoded my payload, right? Well, that's one. So there's a lot of pretty interesting stuff with Base64 encoding. So if I take the letter A and encode that in Base64, and then encode that in Base64, and then encode that in Base64, and then encode that in Base64, let's say 20 times, my 1 kilobyte, 3 kilobyte file could easily grow to 2,000 kilobytes, right? And that might not be such a huge thing, but if that's just one letter, if I have an entire file, this file might be 1 meg. If I Base64 encode that 20 times, 10 times, 15 times, my file is going to be only exponentially larger, right? So now I've got a huge, huge thing I now have to exfil, right, and obfuscate it. So a longer fixed prefix of this, the size, stronger attack detection, right? So for your red team members, this is where you start to think and see through the eyes of your defenders, through the eyes of your SOC analysts, right? This is kind of their thought process behind it. How can I catch you? Well, it's not only how can I catch you, but what behaviors are you doing that got you to this point? So if I'm blind, I have no idea, an alert pops up and I got to look at it. Typically, I'm going to look at the alert, and then I'm going to go into Splunk or something, or whatever my seam is, and then back it up like 10 minutes, 5 minutes, right? Sometimes 30 minutes, sometimes an hour, right? If I see something consistent, if I see a beacon calling out, right? So backing it up. And then adding additional 5, 10, 20, in minutes later to kind of get the picture of what was happening on this box at this time of compromise and digging into it, right? So here we have your blue team. So your blue team's typical job is to obtain situational awareness of your environment, right? So there's nothing worse than a SOC analyst sitting on a network and they have no idea what the network looks like. They have no idea of what's happening. They don't know what devices are on there. How many of you have heard the story or the web server that got plugged into the outlet or connected to the Wi-Fi that nobody knew anything about, And the only way it came about is you were doing compliance, or you hired some pen tester to come in and do it, and found that that dusty box in the server room is actually something that's been sitting on your network that uses a 56K modem or something. When's the last time you guys saw a 56K modem in an environment? Fun fact, I saw one 2 years ago, and it's still there. But again, your blue team members, right, your defenders, detect, investigate, analyze, and mitigate and prevent the threat, whatever the threat is. Could be adversaries of APT level, could be untrained users of your environment, it could be, any number of things. The threat is whatever it is that could compromise your data, right? Your data, your people, your company, your organization's integrity, your integrity, whatever, right? And lastly is to understand, evaluate, and mitigate the risk, right? So that's what the SOC is there for, is really to understand the risk of all these systems and what that means. Evaluate that risk and then mitigate that risk, right? So reporting to your business leaders, here's your lay of the land, here's what we're doing, here's what we got, and here's what I can defend against, here's what I can't defend against. Here's your risk level before we put these effects in place. Here's your risk level afterwards. We lowered it, or we might have lowered it here, but we hired it here, right? So that's really what your SOC leaders are doing. Your analysts are providing that. Your staff within your hunt team, really your whole SOC environment is providing that, right? So for the blue team members in the room, your red team is viewing a problem from an adversary or competitor's perspective. Again, this is location of your building. This is how many people you have, your online social media presence, your just web presence. What do you have on your website, right? That sort of thing, right? Next is your alternative analysis. So for my next giveaway, which is another blue team handbook, who wants to tell me in their own words what alternative analysis means? Nobody? Nobody wants to tell me? Think about it. Alternative analysis. Yeah, go for it. Yes, yes, yes. Come get your book. So your alternative analysis, right? So that's absolutely it, right? It's not the standard way, right? So red teaming is more, again, than just ones and zeros. It's mitigating groupthink, right? So groupthink, you get a group of people in a room, there's countless studies, but one person says, I think this is a good idea, and everybody looks to the boss, and the boss says, I think that too is a good idea, and then everybody else in the room is like, oh yes, that's a very good idea, that's awesome. Like Jim is an awesome guy, he's so smart. And then the next day Jim goes, I have another awesome idea, and he pitches it. And then the boss is like, that is a terrible idea, you're an idiot, what are you doing? And everybody else in the room is like, I'm shunning Jim. Jim ain't cool no more, right? Your red team members analyzes everything that is said, everything that is done, and questions it. Does it stand against my questioning? Does it stand against, let this standard way of doing things? Does it make sense? And is not afraid to speak truth to power. And sometimes that's really hard when you have customers, when you're trying to explain something, and you're trying in a very nice way to say that your environment is not where it should be, right? And you have to do it with senior people in the room, and then say that in a way of your environment isn't what it should be, but then you point to you're not deliberately trying to do so, but you're saying these guys aren't doing you injustice, or trying to identify the pitfalls. People aren't trained. You're not trained on this thing, right? It's nothing against them, but they need training on this. They need awareness to this. They need to be exposed to these things, right? And then you act as devil's advocate. So the whole term for my last book, this is something that I'll be very surprised if people know the answer to. But for the last book, who wants to tell me where the term red teaming came from? Google's your friend. Google's your friend. Go for it. So yes, it is used for red teaming is used for them, but dates back so much further than that, like past medieval times. I'm talking like 1400. I'll ask another question. I'll ask another question for the book, but red teaming came from the idea from the Catholic Church that for sainthood, for people who were put up for becoming a saint by the Catholic Church believed that everybody gets a voice in saying whether or not this person should become a saint, and that includes the devil. So they would pick one person to be the devil's advocate, right? So that's where that term comes from, devil's advocate, to sit back and question every single thing about that person and try and debunk every single thing. They did this one thing. Well, they didn't do that. It could have been this, it could have been that, it could have been that, right? So that's really where the term devil's advocate, which later red teaming, came from, right? So viewing a problem from an adversary, in this case, in this scenario, the Catholic Church, the devil is the adversary, or the competitor's perspective, right? Excuse me. And then lastly, we get to the purple team, right? So again, this is not a new concept, but very few companies, very few organizations are going to grasp this, right? And even in the military, I can't tell you how many operators don't sit next to SOC analysts. They have no idea, the other side of the spectrum in regards to InfoSec, and that goes for the public sector and academia as well, right? So you got public, private, and then academia. They don't know, right? So you have red teamers that totally focus on red team engagements and penetration testing, but they have no idea the artifacts that they're leaving behind. They have no idea the things that they're doing, how loud they are. They think they're being super stealthy, and you're not. You're setting off, alarms left and right? So so the concept of a purple team demystifies each other's operations, right? Each other's thought processes, right? So how did the blue team make decisions? It's not just how do you write signatures, but how did you get to the point to say that I need to write a signature for that, right? So it also enhances communication flow between the two teams, right? So when you get your red team in and blue team in, sometimes they're coming in, and when you first start, they're kicking and screaming because they don't want to sit next to each other. It's a waste of their time. Why are you pitting me with this dude? He doesn't talk, or he or she doesn't talk my language. Like, they don't know. But when you force people in a room together, right, and you say, you can't leave until you figure it out, right? Eventually, they're either going to kill each other or they're going to figure it out, right? But if you foster an environment where it's okay for your red team member to be like, I have no idea what you guys do, right? But you get people in there that's like, I have no idea what you do, but I want to sit next to you, and I want you to show me, right? Let's go through that alert. Let's go through your normal process. Let me think, explain to me your process, right? And if you don't know a process, let's go grab the guy or gal who knows, or let's go grab the policy that states, right? And then on the reverse side, blue team members, again, junior analysts. If you're new to the field, right, so typically one of the very first positions, regardless, red team or blue team, is typically a junior analyst, right, a junior SOC analyst. And then after a little bit of exposure and experience through that, you kind of venture off. You're like, oh man, I really like the attack side. I'm gonna go threat hunting, or let me just make the jump and go pure red team, right? It's not uncommon for people to bounce back and forth, but your junior analysts, they don't know. So if they can sit next to somebody who pulls out their playbook and says, here's how we do stuff. I'm not gonna give you all the tricks of the trade, right? But I can make you smarter. And again, channeling Dave Kennedy in his talk today, in the keynote talk, most of your time as red teamers and penetration testers should be research, should be reading and learning, right? So you're getting to a deeper level as how things operate. So from how things operate, you can convey that wisdom and knowledge that took you months or years to learn, and teach it to someone junior that is, might take like an hour-long conversation, but you just took 10 years of knowledge and condensed it to an hour and just gave them the answer, right? And not only give them the answer, but then challenge them a little bit more to go dig deeper, right? So now you've turned a situation where two entities within the same organization are fighting for each other, are fighting against each other, and now you turn it into a mentorship session. Again, putting my supervisor hat on, right? So, and then each element gains invaluable skills and sees behind the curtain into how each other conducts operations, right? Which is pretty important, right? So you're not just getting 50% of the spectrum. Imagine if we could only see this, right? This is all we can see. And like red team, I see this. I got to hack the things. I got to do the stuff. I got to give the report. Here's how you stop me, blah, 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 blah. I come back 6 months later. Nothing's fixed, right? Let me do it all over again. And blue team says, I got to find the red team. I got to find the adversary. I got to find the threat. Got to do the stuff. And done. Signature written. Implement. Let's do it, right? So from there, you're very narrow-minded. But then if you can pull back the blinders, you start seeing colors for the first time. I recently just had PRK done like a month ago. And the moment I got off the operating table, I was like, oh, I can see everything. I can read that clock, right? It's seeing colors for the first time. And then when you actually get to sit next to someone who knows significantly more than you, and you're like, you come with that open environment of, teach me, I want to learn, share your knowledge with me, right? A lot can go. Those barriers leave, right? So, your questions. Does anybody have any questions for me? It's been a long day. I talked a lot. No water. Cool. So that concludes my talk, but I have one question for you for the last book. Who can tell me what the latest version of XML is? What's the latest XML specification version? Google's your friend. I'll wait this time. I'm done. You know, sir? Oh, you should whisper it to someone. We can make it awkward. I do this with high school students all the time. I ask a question, they'll look at me, and I'll be like, I'll stare at you. Someone will blink first, and it's not going to be me. Oh! Oh! Trying to think of a different one. So, does anybody have any purple team experiences? Anybody have any terrible red team experiences? None? Yeah, let's hear it. Okay. Mm-hmm. Yeah. Awesome. So you've taken your environment, you've done your thing, but then you've done a write-up, and then you've taken the time afterwards to explain that clearly and take technical talk and explain it to officers like myself who have no idea, just, warheads on foreheads. Yeah. Man, that is a solid process, and it's, iron sharpens iron. I'm a firm believer in that. So that concludes my talk. Thank you all for coming. And here is your book. Awesome. Oh, so the most recent XML version is 1.1. So if you paid attention up here is 1.0, right? But the de facto standard is 1.0. Everybody uses 1.0.